All right, let's go over alcohols, phenols, and enols. Now, with your alcohols, they are always sp3 hybridized, meaning that they'll always be in single bonds. So you have different styles being primary, secondary, and tertiary. And this is the section of classification of carbons, which we'll do some review over. For phenols, they are sp2 hybridized because we expect the alcohol to always be connected to the double bond of the benzene ring. For enols, they're also sp2 hybridized, but they're connected, the alcohol is connected to the double bond, same as the benzene ring, but we call this double bond position vinylic. Now, just as a quick recap, for primary alcohols, remember that we're looking at this carbon and we're trying to see how many carbons are connected to this point, which is just one, hence why it's primary. When we look at this one, it's connected to 2, secondary, and then this one here is connected to 1, 2, 3 carbons, tertiary. There's going to be instances where you're going to see Fisher projections. Maybe I should spell it right. Fisher projections. In Fisher projections, you'll always see them look flat, but remember they actually have stereochemistry that they can exhibit. Now, later on, that's going to be a concern when we have to go through possible R&S assignments. But for right now, when we look at this alcohol, that alcohol is connected to this carbon. This carbon is only connected to one other carbon, so this is classified as primary. Now you'll also see what we call Newman projections, and you'll also have to figure out how to assign that alcohol. Now there are easier ways, and that's what all these videos are for, to give you shortcuts, because who wants to go through the whole hectic process? So you see how this alcohol is connected to this carbon right here. Now, this carbon is connected to an isopropyl, so that's one group. I'm just going to star it, or you can put it as a number 1. I can see it's connected also to this CH3 group, which is another, so that's number 2. But then since this carbon is on, the alcohol is on the front carbon is also connected to the back carbon, being the circle, which acts as the 3rd attachment, meaning that this alcohol happens to be tertiary. So there's always shortcuts to doing things. So let's go over a few more examples of classifying carbons. So when you're doing your classification of carbons, you also have when it's in the condensed format. What happens when they shorten it, especially if you have to take the ACS examination, which is a multiple choice standardized exam, they tend to write it more so like this. So the issue is what are the shortcuts we can look for? Well, if you look at where the OH is and the carbon that precedes it, you'll see how many hydrogens are connected to it. Every time it has 2 hydrogens onto that carbon, that's always primary. This one has 1 hydrogen, it will always be secondary. And this one has no hydrogen in between the alcohol and the carbon, and that's tertiary. And guys, there's no such thing as a quaternary alcohol, so don't ask me to draw it, okay? Great. Now going on to different styles to classify the carbon. So for instance, you have this chair conformation. And again, you're looking here, you don't count the bond where the alcohol is, you count the carbon. So that's connected to 1 carbon, 2, and 3, making this tertiary. And sometimes you may have to check mark it just to be sure. We don't want to miss these easy points, not at all. Then here, that's connected to 1, 2, so that's secondary. Here, this carbon is only connected to one other carbon, which is this one, so that's primary. And you can see the shortcut works too, guys, because look at this alcohol. This carbon is connected to 4 bonds. Are there any hydrogens connected to that carbon? I hope you said no. So that's why it would look like this. You see the secondary alcohol is connected to 2 groups, so this carbon has a total of 3 bonds that you can see, but if you draw in the hydrogen, it has 4, so a secondary alcohol has 1 hydrogen. And here you have a primary one, so you see that the alcohol, that carbon has 2 bonds currently, so if I draw the other 2 in, being 2 hydrogens, to complete the octet rule of having 4 bonds, you will see that there's 2 hydrogens connected to a primary alcohol. So my shortcut works. Now when we come here, we have several, I see some OH groups, a lot of different ones. This one right here is connected to the carbonyl. We cannot classify alcohols that are connected to a carbonyl group. This whole thing is known as the functional group of a carboxylic acid. So I'm looking at this alcohol and I'm looking at this one. So this alcohol is connected to this carbon. This carbon is connected to 1 carbon, 2 carbons. So this particular alcohol is secondary. And guys, please be sure to actually point to the carbon when you're assigning the alcohols. Same thing for this one. This carbon, here's my shortcut. I don't have to do the work because I would have memorized that. That one's primary. We did a Newman projection early. Let's see if you understood it. We look at that center carbon where the alcohol is. We see it's connected to the isopropyl group, which is 1. The hydrogen does not count, but then it's also connected to the back carbon, which is the circle. So that one is a secondary alcohol. Now, this group right here is a phenol. I said something earlier, who caught on? Can an alcohol be classified if it's connected to a double bond? The answer is no. Now, and when I say no, it cannot be classified as primary, secondary, or tertiary, but you can classify it underneath hybridization. So remember, what are double bonds classified as? SP, SP2, or SP3? Yep, you're right. Well, hopefully you said that. SP2. So that concludes just the recognition of alcohols, phenols, enols, and how to classify them.